Greetings and welcome. Mid-segments homework. Question 3. Find the coordinates of the endpoints of these mid-segments. Will those done be the midpoints, my friends? Let's find a proper midpoint for D, and then we'll read the other ones right off the coordinate plane. As Tyler, I'm sure you agree, my friend Josh used that method. I think it's a perfectly legitimate method, but I want us to be aware of both techniques. So the midpoint formula, it is simply the average of the x's and the average of the y's. So let's see. 2 plus -6 by the looks of things. Right, Tyler? Yeah. All right. So point D appears to be -5 plus -3 is -8 divided by 2 is negativo quattro. 2 plus -6 is -4 divided by 2. -4 divided by 2 is -2. And notice on the grid, over 4 down 2 does appear to be point D. Let's find point E, which would have been the midpoint of A and B. It looks like it's just at -2, 0. And let's talk point F is -1, -4. Right? Good. So you could have also used midpoints for those. Here it says, show that DF is parallel to AB. Man. So you could use the slope formula. M is equal to y2 minus y1 over x2 minus x1. I'll find the slope of one of those that way. How about we do that? AB, let's find the slope of AB. What am I hoping for these slopes? How will they relate to one another if they are parallel? They're going to be the same. That's right. So 2 minus -2 over -5 minus 1. So this slope is 4 over -6. So that's -2/3 is the slope of, nope, AB's slope. I'm running out of room down there. Yeah, that works. I also could have read slope right off of the graph. Notice this is going down 2 and over 3 units. Down 2 and over 3. Now, is that the same as the slope as DF? Looks like down 2 and over 3. It is. So the slope of DF, DF sub M is what I'm calling it, is equal to -2/3 as well. Therefore, AB is parallel to DF because their slopes are the same. Now, how could I find that their distances are halvesies of one another? Well, that's going to be a matter of the distance formula. All right, distance formula. You guys get it all memorized. Right, x2 minus x1 all squared plus y2 minus y1 all squared. Root that whole thing. Square root. Yeah. And so let's find some distances here, friends. So AB, the distance would be the square root of -5 minus 1 all squared plus 2 minus -2 all squared equals the square root of -6 in parentheses squared. Without that parentheses, you'd likely make a mistake, so be careful, my friends. The positive one in parentheses is not as much of a concern. Where's my scroll bar here? Wow, I'm still only on like the first problem. Yikes. All right, 36 plus 16 looks like the square root of 46 plus 52. Oh, I don't know if you guys know this, but 52 is divisible by 4. If you play cards, you would know that because there's 4 suits in a deck of 52 cards. Come on in. JK, no basketball with the cops, I'm sorry. So let's see, square root of 4 times the square root of 13 is equal to 2 square roots of 13. So that's the length of AB. If I want to find the length of DF, I would use DF's points. I'll do that over here. I think I can fit it. And what were the coordinates of D and F? Oh, I got them right here. Right there and there. All right, so it'd be -4 minus a -1 squared plus negative 2 minus a negative 4 squared. And I'm rooting for this to be what? What number do I want this to be? Square root of 13 is what I'm hoping for. Right? So that's negative 4 plus 1. That's negative 3 squared plus 2 squared. Ooh, guys, I think it might work out. 9 plus 4. Oh, no, you didn't. What? And that is half of 2 root 13. I'm out of space and out of time for this question. All right, here we go. I'm getting crowded here. It says DE is a midsegment of ABC, the triangle. Find the value of X. All right, so DE, if it's a midsegment, that means it connects the midpoints of the sides that it touches. If this is a midpoint, then AE is congruent to EC by def of midpoint, by def of Kong. Their measures are equal. I get X equals 6. The other thing I know is that AB would be twice as long as DE, and those would be parallel to one another. Anthony and I were talking about this. I thought this middle ingredient in this cafeteria tray, which is triangular and scalene for no reason whatsoever, but we agreed that this was probably pretzels. You guys thinking pretzels? We were thinking this was going to be like a slab of meat, but it looks like it's just a sandwich, diagonally cut. Which I don't know who's a fan of diagonal cut sandwiches. Diagonal cut. All right. Good representation. Okay. All right. So you guys are fans of triangles, and you have been for most of your life. Now we know. So let's see. JK. I speaking of cut, I truncated off this K here. JK would have been this mid-segment. Who would that be parallel to? YZ. LZ also works. Yeah, I'll call it YZ. JL is parallel to the who? XZ. Yeah, these ones are easy, more like it. No, never mind. Sorry. Super sorry. I'm so sorry. XY is parallel to the who now? KL. All right. And JY is going to be congruent to who? XJ and KL. All right. So XJ and KL. No, JK. Well, this is not equally angular or equilateral. It looks scalene. I really like this problem. Actually, really intrigues me. I doubt these cafeteria trays actually exist. I don't think they'd be very functional. I think they'd be harder to wash. You couldn't stack them as efficiently in like a dishwasher, I assume. So that makes me wonder, like, did they Photoshop this to make a math problem that related to mid-segments? Did they, like, 3D print a cafeteria tray, put food on it just to get a picture of it?
That looks like a drawing. The middle one looks like...
Yeah, I'm thinking mini pretzels. All right, let's take a look at question 19. Last question. Use triangle GHJ, where A, B, and C are midpoints. It says GH is 7Z minus 1. So, Lauren, that's this one. Don't worry, you don't need to get Malik's attention for this. And CB is this distance right here. We've been given some expressions that relate their lengths. And I would expect that GH is twice as large as CB, or that CB is half as much as GH. So I'm going to do the 7x minus 1 is equal to 2 of the 4z. I wrote X. Sorry. 7z minus 1 is going to equal to 2 of the other ones, 4z minus 3s. And then it's just a matter of the classic algebra with the distribution and the solving and the combining of the like terms. 8z minus 6. Ooh, let's bring those z's together. I'll move the 7 over here. I know. I sometimes just try to avoid having a negative in front of my z, in front of my variables. 8z minus 7z is just a 1z. Oh, man. Wow. Add 6 to both sides. Z is equal to 5. All right, thank you for watching, internet friends. Have a great day. Bye.